Hey everyone, sorry I'm not there today. This was not the plan, but I'm not feeling well at all. So this will be your lesson again. You should have one Chromebook per group right now, and you're working on this together. So make sure that attendance was taken, you guys have your planners filled out correctly, and then that you have filled out the homework check for last night's homework and turned that into the bin. At this point, make sure you have a pencil, a calculator, and your math notebook today. Everything else, go ahead and move it off your desk. And then when the time comes, you'll send a person from your group to get a stack of what I call sequence papers from our guest teacher. They're on my desk. Each stack should have sequences A through J. And you're going to look at 3 problems today, 41, 42, and 44. So notice the homework tonight is 51 to 56. All right, so let's begin. This problem's pretty quick, but today we're kind of moving into what we call sequences. We've been talking about exponential functions, and we've been graphing them and looking at the big rabbit situation and then the bouncy ball situation. Well, today we're going to move into sequences, and the only difference in a sequence is the organization of the way they present the data and the graph. The graph is, if you notice here, it says it's discrete. So that means we will not connect the points on a graph. So starting with problem 41, it says Samantha was thinking about George and Lenny and their rabbits. When she listed the number of rabbits George and Lenny could have at the end of each month, she ended up with an ordered list below called a sequence. Go ahead and take a minute to write down that highlighted definition. A sequence is an ordered list of numbers. That's really important for this. Go ahead and write that down for 41. So our sequence, or ordered list of numbers, is 6, 18, 54, 162, ... means it can keep going. It says she realized that she could represent this situation using a sequence generating machine that would generate the number of rabbits each month by doing something to the previous month's number of rabbits. She tested her generator by putting in a first term of 6, and then she recorded the output before taking that output and putting it into the machine again. Below is a diagram that she used to explain her idea to her teammates. So notice that the first term, so that's the input number 1, and the output is 6. Input number 2, the output is 18. So they don't give us that initial or 0th term like the rabbit situations did. So if we take a look at the picture she drew, she has a sequence generator, she drops in a 6, and out pops an 18. Then she takes the 18, drops it in the sequence generator, out pops a 54. Takes 54, puts it in the sequence generator, out comes 162, and she would continue that process. So take a minute and answer A, B, and C with your group, and then hit play again to see the answers, but these should be super quick. Use your calculator, write them in your math notebook. So at this point, you've pressed play again. It says, what does Samantha's sequence generator seem to be doing to each input? Well, each input seems to be multiplied by 3 to get the next number. Then it says, B, what are the next 2 terms of Samantha's sequence? Show how you got your answer. Well, I rewrote the original, 6, 18, 54, 162, and we know we're multiplying by 3. So I took 162, I multiplied it by 3, and I got 486. I took 486 and I multiplied by 3, and I got 1,458. And then part C, Samantha decided to use the same sequence generator, but this time she started with a first term of 4. So the sequence generator above was times 3, so we're going to use that again. But instead of an input of 6, I'm going to start with an input of 4. So we know my first term is 4. multiply that by 3, I get 12, 36, 108, 324. So just continuously multiplying by 3. So this is like the rabbit situation, and it's repeated multiplication. However, the organization is very different. They talk about first term, second term, third term, fourth term, and fifth term. These here that I'm moving around on the screen are inputs. The ordered list is a list of outputs. All right, so this is where things get interesting. So I need one person from your group to go to our guest teacher and ask for the pile of sequences. There should be A through J in each pile, and you should have one paper for each of them. Once you have that, resume the video and listen for directions. All right, so Samantha and her teacher have been busy creating new sequence generators, and the sequences they produce below are the sequences Samantha and her teacher have created. So you should have A through J on pieces of paper provided by our guest teacher. Your teacher will give you a set of resource pages with the above sequences on them so your team can see and work together in your workspace. So make sure the desk is clear. You should only have your math notebook and the Chromebook out, maybe a calculator, definitely a pencil. And we're going to do 3 different sorts with these. So the first sort number 1. I want you guys to consider the growth pattern that you see in the sequences, but you're not going to write on the tables or the graphs. You are just solely looking at the sequence at the top of the page. So just for reference, this is what your pages should look like. You're focusing on just the sequence up here at the top of the page for A through J. So I would like you to look at the growth pattern and then sort, rearrange, and record these families into your math notebooks. So I have a sample down here, growth by addition, growth by subtraction, growth by multiplication, growth by division, and then an other category. You might have one, you might not. There's no right or wrong here if you think you can figure it out. So go ahead and pause the video, do your sort, and then take about 2 minutes, 3 minutes, and then come back and check your answers with the example sort that I have on the screen. Okay, so it's probably been about 3 minutes. You probably started your video again. This is my example sort. So for addition, I had sequences A and D. Subtraction, I had F. Multiplication, I had sequences J and sequence B. For division, I had sequence G and sequence H. And then I had an other category for sequences I, E, and C. It is okay if you placed I, E, and C somewhere else. That's totally fine. This is just an example on the screen. Just move that up. Okay, make sure that is recorded in your math notebook so we can go back to it later. But we are going to go on to sort number 2. So sort number 2 says complete the table and the table only for each of the sequence papers. You're going to then resort them, rearrange where you need to, and then record your new findings. Some of you might not change anything. Some of you only might change 2 or 3 of the sequences. But remember, you're just completing the table. You are not completing anything else, no graph yet. And in the table, you only need to go from 1 to 7 for the N column, which is your inputs. And then from T of N and your outputs should match how many inputs you used. So go ahead and pause the video, divide these up amongst the people in your group, fill out the tables, and then resort them and record them in your notebooks. Then check with what I have on the screen. Okay, so you are probably pressing play again. You should have already sorted them yourselves, completed the tables, and then tried to resort them. Below is an example of a resort you might have done. And I'll talk about a few of the specific tape or sequences that I changed. So if we take a look, this is for sort number 2. If you notice the addition one, I added 2. E is adding the 2 previous terms. So 1 plus 1 gives me 2. 1 plus 2 gives me 3. 2 plus 3 gives me 5. 3 plus 5 gives me 8. This is actually a special sequence called the Fibonacci, but it is based off of addition. And then we have C. Some of you might have put C here because you are adding the next odd. So between 0 and 1, I add 1. Between 1 and 4, I add 3. Between 4 and 9, I added 5. So I added the next odd each time. If you did not move them, that is totally fine. Some people might have, some people might not have. But my other categories really didn't change besides the actual other category. It only has I in it now. So this is just an example. If you didn't change much, that's okay. This one probably took you closer to 5 minutes because of all the writing you had to do. Okay, so we have one more sort, and it's sort number 3. So now I want you guys to complete the graph for each of the given sequences, resort them based on the graph, and then finalize your decisions and write them in your math notebooks. So divide and conquer again. Everyone should just be graphing the ordered pairs from the table. So just a reminder, it said sequences are discrete, so we do not connect the points on these graphs. So go ahead and press pause, divide these up, graph them, and then resort them based on the type of graph you see. Linear, exponential, or maybe you see something that's nonlinear that just doesn't fit. And that's my other category down there. Okay, so you're probably pressing play again. And here is the example of what you should have for your final sort based on the picture, aka the graph that you created. So A, D, and F were linear graphs. B, G, H, and J were considered exponential based on how they look. And then other or nonlinear would be C, E, and I. Because they don't have a multiplier, so they're not exponential, but they kind of have a curve to them, so we'll talk about those later. But make sure these 3 categories are recorded in your math notebooks so we can talk about them later. Okay, so we are on to the last question for today. All right, so with this question, 44, it says, some types of sequences have special names. What I have highlighted in parts A and B needs to be written down in your math notebooks. These are definitions for 2 types of sequences that we are going to continue to look at throughout this chapter, and again later on in this course. So it says, A, when a sequence generator adds a constant to each previous term, this is called an arithmetic sequence. So arithmetic sequences add a constant term. Which of the sequences from our sort fall into this family? Please list them. Should we include the sequence labeled F in this family? Why or why not? So pause the video, go answer that with your groups, and then we'll move on to B. Okay, so now we're probably back. You've pressed play. Part B now says, when the sequence generator multiplies a constant times each previous term, This is called a geometric sequence. So geometric sequences have a constant multiplier, very, very similar to exponential functions. So my question is, which of the sequences from our sort in the last problem are considered geometric based on that definition? And should sequence H be in this group? Why or why not? So go ahead and pause the video, answer that question, and then we will talk about the answers for both. Okay, so we are back taking a look at A. Sequences A, D, and F are all considered arithmetic because they add a constant term, very similar to linear functions or linear equations. We do include F because subtracting 2 is like adding a -2, so we're good there. And then in B, sequences B, G, H, and J are considered geometric because they have a constant multiplier. And we include H because dividing by 3 is the same thing as multiplying by the fraction 1/3. So that multiplication and division really go hand in hand. The addition and subtraction go hand in hand as well for arithmetic sequences. So make sure what we just revealed, A and B, is written in your math notebooks under 44. It is important that you get these definitions down that are highlighted up here. So again, make sure you wrote those definitions in your math notebook notes. And then you guys can start the homework for tonight. Homework tonight is 51 through 56. If you have already done that, please go ahead and work ahead on tomorrow night's homework with the time that you have left in the period. And hopefully I see you guys on Friday. All right. All right, guys. I'll see you later.